Assalamualaikum and good day, everyone. The next topic in this chapter, chapter 3 here. So we have done with how to transform and how to inverse transform. Now we are going to apply all of those knowledge to solve differential equation by using Laplace transform. So basically, we have steps here in solving the differential equation of IVP and BVP by using Laplace. So first we have to rewrite the equation in terms of Laplace transform, and we are going to insert the given initial condition. All right, and then we rearrange the equation algebraically to give the transform of the solution, and we determine the inverse to obtain the particular solution in the original domain. So now, before we transform, we should use the transformation of derivative here. Okay, when it is y, the transform becomes ys. When it is y prime, the transform becomes sys minus y naught. So let's take a look at this example where it involves only first derivative of y, dy dt here. Okay, so we're going to go step by step here. So first step, we need to rewrite the equation in terms of Laplace. Means that we have to transform everything in the given equation. So we have here dy dt, okay, and then we have in transform of 2y, put 2 outside because of the linearity property, and we transform 4 here. Okay, so dy dt is actually y prime. Then the transform version becomes sys minus y naught. And y become ys. And transforming 4 by using the table of transformation, 4 is a constant, transform constant, you will have 4 over s. Okay, then we insert the given initial condition where when t equals to 0, y equals to 1 means that y0 equals to 1. So here just substitute with 1. And then rearrange the equation algebraically to give the transform of the solution. So we put the function of s, of ys here. So rearrange, and then we have 4 over s plus with 1. So factorize ys here. We have s minus 2 here. And then we give the transform of the solution. So the solution of ys should be 4 over s plus 1 divided by s minus 2 will give you 4 plus s over s minus 2. So this is the solution in terms of s. Remember, we have the problems in terms of yt. We transform yt by using Laplace transform, we get ys. Okay, and then we have the solution in S domain. So in solving DE, we are going to go through this process, and then we want the solution in T domain. Then we need to do inverse transform of ys. Now, our solution here is in terms of ys. Now we want to get yt, means that we have to transform the solution of s here. Okay, so as you can see, this is a fraction where the denominator is a combination of s and s minus 2. And then we can simplify by using partial fraction. So now 4 plus s over s minus 2 can be simplified to a over s plus b over s minus 2. So as you can see, the denominator here has a linear factor. Then we just have to find the value of a and b here by partial fraction. So substitute and multiply here. We have, and we combine with the left hand side of 4 plus s. Then we have a equals to minus 2 and b equals to 3. So instead of from here, in order to find yt, instead of inverse transform of 4 plus s over s minus 2, now we inverse transform of minus 2 over s plus inverse transform of 3 over s minus 2. So put 3 outside here by linearity property, put the constant outside. So we have our yt equals to, this is a constant, plus 3 exponent 2t. So this is how we solve the differential equation by using Laplace transform. First, what we have done here, first transform everything, and then insert the initial condition here, and then rearrange so that you have the solution in terms of ys. And then in order to get yt, you need to inverse transform. So this is second step. This is your third step. And then what we did here is inverse transform by using partial fraction. And then we are going to have our final solution is in terms of yt. So these are the steps of solving differential equation by using Laplace transform. So for this example, what we have done here only for first derivative, first order of differential equation. Okay. All right, so now let's take a look at this example where it involves second order of differential equation. Same process. Okay, we have to transform. So how can we transform second order? Y double prime here is given by s squared ys minus sy naught minus y naught prime. Okay, so first step is to transform every coefficient here. So we transform, this one is y double prime, transform y prime, transform y, and then transform exponent 3t here. So transforming y double prime will give you s squared ys minus s y naught minus y naught prime. Okay, and then minus 3 here, y prime, transforming y prime will give you sys minus y naught, and then transforming y will give you ys, and then here transforming exponent to the power of 3t will give you 2 over s minus 3. Okay, and then substitute the given condition y naught equals to 5, y naught prime equals to 7. So here again rewrite y naught equals to 5, y naught prime equals to 7. Okay, so here we have 5s minus 7. This is 3 sys, and y naught here is 5, so plus 15 plus 2ys equals to 2 over s minus 3. So rearrange by putting all coefficient with ys in the left hand side, and then the rest put it to the right hand side. So here we have s squared ys minus 3sys plus 2ys equals to 2 over s minus 3 plus 5s, 15 minus 7 minus 8 here. Okay, and then factorize, we have ys s squared minus 3s plus 2. So 2 over s minus 3 plus 5s minus 8. So this one we can factorize. Here we will have s minus 1, s minus 2. And then put this s minus 1, s minus 2 to the right hand side. Will give you so now we want to find yt. So this is actually ys. Okay, let me write it again here. So ys equals to 2 over s minus 3, s minus 1, s minus 2 plus 5s minus 8, s minus 1, s minus 2. So as you can see, this is ys. So in order to get yt, what you need to do is to inverse transform of ys. Okay, now we want to find yt. Okay, so here ys is 2 over s minus 3, s minus 1, s minus 2 plus 5s minus 8, s minus 1, s minus 2. So we just can combine this. Okay, 5s minus 8 times with s minus 3. Put it all together. Okay, and then we can decompose this to a partial fraction where we have a single linear factor there. So what you need to do here is to find the value of A, B, and C. Oh, before that, sorry. Okay, so first you can see here we have s minus 3, s minus 3. We just can simplify that. So we have only two factors. So it is A over s minus 1 plus B over s minus 2. Sorry, there is a mistake here. Okay, now we want to combine these two. Okay, so this 5s minus 8, we just multiply with s minus 3. All right, before we can remove and factorize, we should expand this first. So we have 2 5s squared minus 23s plus 24 divided by s minus 1, s minus 2, s minus 3. And this can again be simplified and factorized to 5s minus 13, s minus 2. After we expand this, and then we put these two together, and then we have to factorize this so that we can simplify the function. Okay, then we have here s minus 1, s minus 2, s minus 3. Okay. And then we can simplify s minus 2 and then s minus 2. So what's left is 5s minus 13 over s minus 1, s minus 3. And only here we can decompose to a partial fraction of a over s minus 1 plus b over s minus 3. So from here, you just can solve this by using partial fraction. Since this is a linear factor, so from here you can find your a and b, where a equals to 1 and b equals to 4. Okay, and then in order to find yt, you need to inverse transform of ys, where you inverse transform the partial fraction that you have obtained. So 1 over s minus 1 plus inverse transform 4 over s minus 3. Okay, we can put this 4 outside by linearity. So we can have here exponent s minus 3 here. Sorry, s minus 3, s minus 1. S minus 3, s minus 1. Okay, I just rearrange here. If you have changed the position of a and b, it doesn't matter as long as it has x denominator together. So we have the solution of exponent 3t plus with 4et. So this is how you obtain yt. Okay, so the process here consists of transforming, apply the condition, these two, y naught and y prime naught, and rearrange. So what we did here, rearrange, and we have the solution in terms of ys, and we inverse. But before inverse, we need to simplify, and this is our yt. Okay. So basically, this is how we use Laplace transform in order to solve the differential equation. So what I have shown here is the transformation of the first order of differential equation in example 23, and the transformation of second order of differential equation in example 24. Okay, so thank you everyone.